All right, so we're talking about pure substances, elements here today. So again, pure substances can be elements or compounds as long as it's only one type of thing, one type of element or one type of compound. What are elements? Well, the periodic table of elements has a list of all of the naturally and even lab-created elements that are in existence today, or at least that we've discovered today. So elements are made up of only one type of particle that cannot be broken down into simpler substances. And we talked about this the first day. There are particles inside of atoms, so we can actually break down an atom into protons, neutrons, and electrons, but those particles are not still that atom, right? So if we're talking about the smallest piece of a substance, of an element, that's an atom. So an element is just the most basic kind of thing that we can have. For example, neon. So you look at neon lights, the different colored lights that you see at night in some restaurants and things like that. That's a gas, so that's neon. It's number 10 up there. You can see it on the periodic table. And it's an element. Also, number 19. What's number 19 there? You see number 19? That's potassium, K. And sometimes the element symbols are letters from the English name of the element, and sometimes they're not. Sometimes they're letters from the names of the elements from a different language. Sometimes they're named after people or places and things like that. So K and potassium. That's this K is a symbol for potassium. It's from the Latin name for potassium. So we have nickel, and we also have gold. Au is Latin for gold. Aurum is the Latin word for gold, and that's why it's Au. But the elements that are on that periodic table of elements are the basic elements, the simplest elements. Okay?
I wish we just had water, earth, fire.
Oh, why? You wish we just had water, earth, and fire. Okay, well, maybe a little bit. Yeah, there's fewer of those to remember, I guess. But okay, so types of pure substance elements. Let's continue. Diatomic elements, and you should have some blanks in your notes here again. So diatomic elements. Now, this is something that I want to introduce to you. If we have a plain, a sample of just pure hydrogen. So let's say we have a balloon full of hydrogen gas. Well, there's only hydrogen in there, but there are 7 elements that are special in that if they are in elemental form, they always pair up together. So it always be H2 sort of molecules. Instead of just individual atoms, they always buddy up. And those are called the diatomic elements. So in your notes there, you want to fill in diatomic. And Di is the prefix that we use for two. Two atoms, 2 atoms. So they would exist in pairs. And those are hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. And these are the blanks that you want to fill in. Now, there's 2 things that will help you remember this. Which ones are the diatomic elements? This one is it looks really interesting, but if you remember the word Hofbrinkel, it's a strange word, but it's easy to remember. Hofbrinkel, H, hydrogen, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine. That's Hofbrinkel. The other way to remember this, on your periodic table kind of looks something like this, right? And we have hydrogen over here. The other elements after hydrogen actually form, they kind of line up like this, and it makes like a little bit of a 7. So 1, 2, 3, 4, 5, 6 over here make a little shape of a 7.
Is that what this is?
All right, so here's a copy of the periodic table, and each of these elements on the periodic table have a special position. They have special characteristics. It's organized in a certain way, which we will talk more about as we move through science. But yeah, you see the list of elements there. Okay, so where were we here? The diatomic 7. Okay, so fluorine. Oh, I should probably point out fluorine. Fluorine is spelt a little bit weird. Some of these elements are spelt a bit weird. Usually words with like this sound O, orine, is usually OU, but fluorine is actually UO. So when you're spelling these things, pay close attention to the words because some of these are a little bit strange. Okay, the diatomic 7. Okay, what about compounds? What do compounds have to do with things? Well, as I mentioned, compounds are combinations of elements that are chemically bonded together. And you can still have a pure compound. Like, for example, if we had a substance, if we had a glass of pure water, well, first of all, it wouldn't really taste very good because we're used to having different metals and ions dissolved in our water, to tell you the truth. So if you had a pure sample of water, only H2O, it would probably taste a little bit funny, actually. But it's possible to have a pure sample of water, only H2O molecules. That's it. No other contaminants. And so compounds are made up of 2 or more elements chemically combined. And in your notes, you're going to want to write out the chemical formula for water. And I think I have a space for you on the right. It's a little more room. But H2O is water. We talked a little bit about this, I believe, first class. The reason why it's H2O is because in this chemical compound, there are 2 hydrogens and 1 oxygen, and they're bonded together. So they always exist as a molecule like that. Carbon dioxide, well, that has carbon and oxygen. The formula is CO2.
What should we write next to it?
Well, you're writing the formulas here. And sodium chloride is salt, NaCl. So when there's no numbers on a compound like this, that means 1 Na and 1 Cl. So it would look like this, like maybe Na is here and the Cl is here, just 1 to 1, they're just bonded together. So the formula NaCl. So it is, when you're writing formulas for these compounds, please make sure you remember the capital letters and the lowercase letters. So it's not okay to write sodium chloride like this. Okay? So not all lowercase, also not all uppercase. Okay? That's not cool either. So don't take it upon yourself to kind of like, just change it up a little bit so that you're a little bit different or express yourself this way. Please write the formulas the way they are on the periodic table. That's how they're correct. So when there's 2 letters in a symbol, the first one's always capitalized, the second one is always lowercase. Okay? And when there's only 1, it's always capital. All right? Got it? Any questions? All right. Doing pretty good. Okay, next page. Mixtures. Okay, so we had pure substances, and now we have mixtures. So mixtures, as the name suggests, is when we mix types of things together. So a mixture is a combination of pure substances. Mixtures can be separated by physical means. Physical is the space you want to, word you want to put in that space there. Okay, so a combination of pure substances and mixtures can be separated by physical means. Now, what do we mean by physical means? Okay, the 2 types of methods to separate something like this on a molecular level or in a sample would be physical separation, and then there would be chemical separation. So if you think about physical means, we're going to talk about physical properties and physical changes here soon, but physical means literally means you can pull them apart like physically, or you can cut them and separate them physically, okay? You don't have to like mix in a solution and mix it up and then boil it and then, collect half of it here. That would be like a chemical separation. Physical would be literally like cutting it up or just pulling pieces apart, okay? That's physical means. These substances do not combine chemically. The substances are mixed, but they still stay in their original form. So the little spaces you have there, these substances do not combine chemically. Okay. So there are some examples that we'll go through here, and I don't mind mentioning them right now, but think about, and the one that's kind of the one that comes to my mind always when I think of like a mixture like this that you can separate would be like a chocolate chip cookie. We all love chocolate chip cookies, right? Anybody not like chocolate chip cookies here? All right, kind of, some hands going up. All right, well, hopefully one day, you'll learn to like chocolate chip cookies, but no, it's okay. But if you think about chocolate chip cookies, okay, you have the chocolate chips and then you have the kind of the cookie dough, like the cooked cookie dough. So there's really kind of like 2 parts to this mixture. The chocolate chips could be considered one sort of, pure substance, and then it's kind of mixed in physically, just folded in, just plopped in to the cookie dough, and the cookie dough would be the second sort of pure substance. So a mixture is where you have, two or more different types of substances that you can see the differences, that you can actually, filter out one from the other, or you can literally cut one out or pluck one out that way. Combining chemically would be sort of like the cookie dough itself. Let's think about that. I don't know how to make cookies very well, but like if you mix, your flour and eggs and sugar and stuff like that, and you mix it together and you put it in the oven. Now those parts are going to chemically combine, right? They're going to actually be a chemical change. So if you think about the cookie dough as part one, the chocolate chips as part two, you can separate that cookie, okay? All right, there are three types of mixtures. The three types of mixtures are mechanical mixtures, and we'll talk more about these as we move through today, suspensions, and solutions. There are three types of mixtures: mechanical, suspension, and solution. So we'll focus on what each of those three look like here. Let's first talk about mechanical mixtures. The different types of substances that make up the mixtures are visible. An example would be, and here's a picture of it right down here, the chocolate chip cookie. Okay. This picture, I believe, is pizza. This picture is pizza. And to tell you the truth, I have no idea what this picture is.
Gravel.
It could be gravel. Yeah, does it look like gravel to you?
It says gravel.
Oh, it says gravel above. Thank you. I missed that. I haven't read that yet. So this is gravel. Very good. Oh, you guys are quicker than me this morning. Where's my coffee? I need to drink more coffee, I guess. I need to be more awake. All right. So yes, so we have, and right here, pizza, chocolate chip, cookie, and gravel. Just looking at that picture, I would never be able to tell what that is. Just that's a bad photocopy. But anyways. Okay, so a mixture in which different parts are visible is called heterogeneous. Okay, it's a big, long scientific word there. Hetero means different. So these are combined with different parts. Okay, heterogeneous. So, yeah, examples here. The first picture, pizza, chocolate chip cookie, and this is gravel. Okay, very good. Mechanical mixtures. The parts are visible. And for the most part, fairly easy to separate. Mechanical mixtures. What about suspensions? Well, if you were to suspend something, okay, think about hanging something. You're suspending something. You're hanging something in midair. You're suspending it. So that's kind of the vision that you want to think about. Tiny particles of one substance are held within another to create a cloudy mixture. Okay? A cloudy mixture. Now, this is often maybe little pieces of solid, or little pieces of maybe one liquid inside another liquid even. So tiny particles of one substance are held within another to create a cloudy mixture. The particles in the mixture can be separated when poured through a filter. So a chocolate chip cookie would not be a suspension. That's a mechanical mixture. They're easy to pull out the chocolate chips there. Okay, something like tomato juice, okay, or even milk, thick milk or something like that. If you were to pour the liquid, let's say, through a filter, you would get maybe one liquid coming out the bottom, and then you have little bits of parts inside the filter that would stay in the filter. It would be in the filter. So that's a suspension. And sometimes it just looks like a cloudy mixture and you can't really see the parts, and sometimes you can actually see the parts floating around in there. Like a smoothie? Okay, that's a good one. Yeah, I suppose a smoothie. Yeah, I guess, yeah. I think that would be a very good example, smoothie. And mixed fairly well, right? If you have like big chunks, you might say, oh, that's maybe more of a mechanical mixture. They're really visible. But if the smoothie is sort of like one cloudy sort of looking thing, if you can't really pick out the separate parts, that would be a great example of a suspension. Yeah. It's hard to pick out the different parts when you just look at it in a suspension. All right. This is also a heterogeneous mixture. So again, if there are separate parts, that exist, they're just a little bit tougher to see in the cloudiness. Okay, solutions. So here we go, a third type of solutions. In a solution, the different substances are not individually visible. So this would be, you're looking at something and it looks like it could be a pure substance. It doesn't look like a mixture because you can only see one sort of thing in there, for sure. And usually in a solution, one substance is dissolved inside of another. So one substance is dissolved in another. Okay, and when we dissolve something, the pieces separate, and those little pieces are so tiny that you really can't see them anymore to the naked eye. So mixtures composed of particles that cannot be seen individually are called homogeneous mixtures. Okay, homogeneous, homo meaning one. So hetero is different, separated. Homo is together one. So examples would be tea, or even if you mix some sugar and coffee, right? Or if you were to have a glass of water and you put salt in there even, and you mix it around, boom, the salt disappears, right? Well, it doesn't disappear, it just dissolves. So it breaks up into particles so small that you can't really see them anymore. And so vinegar even is one. Vinegar has water and acetic acid. That's what vinegar is. So yeah, one substance dissolved in another. Now I did have at the bottom of your paper there too, alloys. Okay, so alloy is something that's we need to talk about, but it's just kind of an add-on here to your notes. But an alloy is when different kinds of metals, and you'll have to write this whole definition out here, I don't have any blanks for you. Different kinds of metals are mixed together in liquid form. So yes, it's possible to melt metals. It'd be very, very hot, very high temperature. And then they've been cooled down or frozen into solid homogeneous form. Okay, so that's what an alloy is. It's a mixture of metals. So this could be your fourth type of mixture, really. And bronze or stainless steel, different things like that. You'll see on bikes even like maybe aluminum alloy or something like titanium. So usually those aren't pure substances. Usually they're mixed with other metals to strengthen them or to give them different characteristics. So if you have a gold ring, let's say, it could be pure gold, but chances are it's mixed with other metals to maybe make it stronger.
So is that what they call it, like 24 karat?
Yeah, the carat, like 24 karat gold, 18 karat gold, 10 karat gold, that would be the sort of the amount of how pure it is. So it would be mixed with other things. That's right. The higher the number, the more pure it is. Here. So we got a question about gold medals in the Olympics. So gold medals would be coated with gold, not pure gold. So they're actually looks like they're silver. They're silver, cylinders here, coated with gold. So the gold medal. So there's not pure gold.
So I guess you don't really win.
They would be would it be an alloy? It's not even really an alloy. It's an alloy would be where you have the silver and the gold all melted and mixed together, and it's one kind of solid thing. This one is kind of pure silver, and then on the outside they just kind of dipped it in, a gold kind of solution and some electricity and whatever, and just different chemicals in there, and then the gold atoms would be basically stuck on top of the silver atoms to make it look gold. Yeah, so covered in gold, and a lot of jewelry is kind of like that. Okay, I have this little chart here. on your paper. Now, this would be something where you would kind of work out what kind of substance it is. Is it pure substance? Is it a mixture? Would it be heterogeneous, homogeneous? Would it be a solution or whatever? And so this is something we'll do a little example here. Maybe with this. Let's do the chocolate chip cookie. Okay, so on your little paper there, this would be a good exercise here. So let's say let's say a chocolate chip cookie, okay? Yeah, chocolate chip cookie. Chocolate chip cookie, okay. So the first question would be, can this substance be separated by physical means? So remember what physical means is. It's like cutting or plucking or like, just shaving off or something. You're not actually dipping it in acid to dissolve it, to separate it. It's just physical means. It's just like crumbling or picking or cutting, like that kind of thing. So a chocolate chip cookie. Do you need to dissolve it in some kind of chemical substance to separate the pieces? No. So yes, it can. Okay, so yes, it can. So we're going over here. Now the chocolate chip cookie, I'm just going to draw it over here. Here we go. Looks like a person. You don't have to draw it, but I am going to draw it here, okay? Are the different substances individually visible? Okay. So are they individually visible? Well, it looks like the dough and the chocolate chips would be the two parts of this, and they are definitely visible. Okay. So we're going to go here, yes. And you're going to have your chocolate chips here, chocolate chips, and then the crumbly cookie dough, right? Okay. So these are chocolate chips and the cookie dough. All right. So what kind of mixture is this then? If we can separate them, it's obviously going to be, well, let's go back. Let's go back is it a suspension? Do you have to like pour the cookie parts through a filter to separate them? No, not a suspension. What about a mechanical mixture? Well, we've got the cookie listed right there, actually. It is a mechanical mixture. The other one was a solution. A solution would be like, solutions are usually liquids, and it just looks like clear, usually. Solutions are usually clear liquids that technically have more than one thing in there. Okay, question?
Would a paint be a solution or a suspension?
Paint?
Yeah.
Okay, so let's label this one, and we'll come back to that one. Okay, let's label this one. So the chocolate chip cookie. So what do we got for chocolate chip cookie? What is it? It is a mechanical mixture. Mechanical mixture.
Do we have to write that part? No.
Yep, mechanical mixture. That's right. So this is sort of what this would be over here. Now, what if the parts were not individually visible at all? What would that be? Yes, a solution. Yeah, you bet.
Then you'd have to filter it.
Well, so the filtering would come with the suspension. Okay, so are the substances individually visible? So a suspension would probably fit in here as well, right? Suspension. And of course, if they weren't individually visible, we could probably put an alloy in here too, right? Remember alloy? We just looked at alloy too, so we could write alloy down there too. That would probably fit over there too. Well, if they weren't individually visible. So remember if we had like different metals melted and then mixed all up together and then frozen into a shape or whatever, that could be an alloy there too. Okay. Okay. Awesome. All right. So we're just going to focus on that for now. So we also had a question about paint, and is it a solution? Is it what kind of mixture would it be? And technically paint would be a colloid, which is like a suspension that never settles out. So a suspension over time, you would have parts kind of settling out and you would see more of a separation. But a paint's not a true solution because there's different parts in there that could be separated difficultly, but it's technically called a colloid. So good question. Paint's a tricky one. All right, so we're going to pause there. I want you to write these questions down in your textbook, chapter 4. I'm going to get you to work on these questions because everything that we've studied so far here is going to be covered in these questions, and there will be some questions towards the end that will talk about chemical changes and things that we haven't yet discussed. So I'm going to get you to write this as your assignment down, and I'll tell you exactly what questions you'll probably be able to do from what you know so far.
All of them.
I didn't call you this weekend.